So today we're going to build on our idea of graphing stories. So for this warm-up today, we're going to take a look at 3 situations. And in class, I assigned everybody a different situation to graph. So a dog owner tied his dog's 5-foot leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within minutes. So we're going to describe the day's movements. So day 1, the dog walked around the entire time while waiting for its owner. If you were assigned the first day, you do that. Day 2, the dog walked around for the first minute, then laid down until its owner returned. And day 3, the dog tried to follow its owner into the store, but it was stopped by the leash. Then it started walking around the post in one direction. It kept walking until its leash was completely wound up around the post, and the dog stayed there until the owner returned. So each day the dog was 1.5 feet away from the post when the owner left. And each day, 60 seconds after the owner left, the dog was 4 feet. So if I was to graph day 1, I know, I'm going to put that this red is day 1. What do we know? It was 1.5 feet away when it left. And we know after 60 seconds it has to be at 4. So the dog walked around the entire time. So could go, there's lots of different ways, but it has to be moving the entire time. So what could day 2 look like? The dog walked around for the first minute, so started the same, so maybe it and then laid down until the owner returned. So it would level out there. And the third day, day 3, the dog tried to follow the owner in the store but was stopped by the leash. So if it's stopped by the leash, what does that mean? Well, it's got to go all the way up. Then it started and we know it has to be 4 feet away at 60 seconds. So I think I need to switch day 2. Because my bad, day 2, I forgot that second part for day 2. At day 2, it has to be 4 feet away. So we know it has to rest up there. My bad. And let's see. Then it started walking around the post in one direction. It kept walking until its leash was completely walked round around the post. So if it's going back to the post, it's got to come down and be 0 distance from the post. So we're talking about how this dog's movements are. So what we're going to talk about here is the relationship between those. Since the dog owner left and the total distance is the dog and how far away the dog is a function. In a function, which variable is independent and dependent? Well, what's independent? Well, the time. And then the distance where the dog is, because the distance depends upon the time. So write the sentence in the form, distance is a function of time. So our definition here, a relationship between two quantities is a function if there is exactly one output for each input. We can call the input the independent variable and the output the dependent. So in our case of time, if I asked where the dog was 3 feet from now, you would just give me one answer each day. It wouldn't give me 2 answers. If I said 60 seconds away on day 1, you would have one location. You wouldn't have multiple ones. So I want you to take some time on these and complete the sentence below. What is a function of what? So what depends on the other one? And you can see there's lots of different things here that you can choose from. So for example, your cell phone will. So your cell phone bill is a function of how many minutes you used. In the old days, you used to get charged per minute. I would say the results of a soccer game is a function of who scores more goals. So it depends on who scores more goals. So why don't you take some time and see what you can fill out there. So now we're going to take a look at some examples of these functions here. The relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. Identify the independent and dependent variable. So the cost is our dependent because it depends on the hours it parked. So describe with a sentence of the form is a function of. Cost is a function of hours parked. Suppose it costs $3 per hour to park with a maximum of 12. So sketch this, okay? So 1, 2, 3, 4. So this would be hours. And I'm going to do money here. So 3, 6, 9, 12. So 1 hour is 3, 2 is 6, 3 is 9, 4 is 12. And then that's the maximum. So it would just hold steady. So the second one here, the price of different burgers are shown on this sign at the right. Based on the information from the menu, is the price of the burger a function of the number of patties? So does the burger depend on the price of the patties? Well, if I look here, these are 2 patties. So does the price depend on the patties? Well, no, it's dependent on the cheese. So I would say no, because you input 2 patties and you get 2 different costs. And then the last one here. The distance a person walks d in kilometers is a function of time in minutes since the walk begins. Select all statements which about the input variable. So what is our input? Well, time is our input. That's how far they walked. Time since a person starts walking is the input. So is it time of day or time since they start walking? Well, t a minute since the walk begins. So it wouldn't be this one. It'd be letter C. T is the input. The input D is distance, so that's not the input. The input is not measured in units. Well, it says it's measured in minutes. For each input, there are some 2 outputs. Well, no, because that distance will always be changing. So what we're going to have you guys do tonight is go to Schoology, and there is a Desmos assignment called Independent and Dependent Variables.